Have you ever thought about how a GPS knows exactly where you are, or how a video game character moves across the screen? Well, it all comes down to a simple grid, a kind of secret map for, well, pretty much everything. Today, we're diving into that map, the coordinate plane.
So here's the big question, right? How in the world can just two little numbers tell you a precise location anywhere on a map? It sounds way too simple to work, but this one idea is the powerhouse behind everything from navigating the globe to designing the graphics in your favorite game.
The whole system is actually built on just two simple intersecting lines. First, you've got the x-axis, which runs side to side, horizontally. Then you have the y-axis, which goes straight up and down, vertically. These two lines are basically the main roads of our entire map.
And the spot where these two main roads cross, that's our ground zero. We call it the origin. Think of it as the big "you are here" star on the map. Every single journey we take, every point we plot, it all kicks off right here at 0, 0.
Now, when those two axes cross, they slice the map into 4 sections. We call these quadrants. And this table here, this is basically our cheat sheet, our map key. Each quadrant has its own unique code based on whether the numbers are positive or negative. For example, if you have 2 positive numbers, you are always going to land in Quadrant I. It's a super handy shortcut. So to really see this in action, the source material for this explainer uses a few well-known figures as landmarks. Let's get our directions and find them on the map. First up, we're looking for Moses. Okay, our instructions say Moses is at the coordinates 3, 2. Now, the golden rule here is you always use the x value first, then the y value. So our directions are 3, then 2. Let's start the trip. Remember, we always start at the origin, 0, 0. Our first number is a positive 3. Since it's positive, we move 3 spots to the right along that x-axis. From that new spot, our second number is a positive 2, which means we go 2 spots straight up. And there we are. We've landed right in Quadrant I. And if you think back to our map key, that's exactly where a positive point should be. See? The system works perfectly. All right, time for our next trek. This time, we're on the hunt for David, and his coordinates are -4, 5. Now pay attention here. Our first number, the x value, is negative. That's going to change things. So back to our starting point at the origin. The first number is -4. That negative sign is our signal to go left this time, 4 units over. Then our second number is a positive 5. So from there, we move 5 units up. And that puts us smack dab in Quadrant I. A negative x and a positive y, which, if you check the map key, is exactly what we expected. The pattern holds up. Okay, one last location to find. We're looking for Esther, and her coordinates are -3, -6. Now we've got a double negative on our hands. Let's see where that takes us. For the last time, let's start at the origin. That first number, -3, tells us to move 3 units to the left. And the second number, -6, tells us to move 6 units down. And our final destination is Quadrant 3, which is home to all the points with 2 negative numbers. So that's really the main takeaway here. Don't let those positive or negative signs freak you out. They're just simple directions. Positive means right or up, and negative means left or down. That's it. Okay, so we've explored the 4 main neighborhoods of our map. But what happens if a point is kind of a rebel? What if it's not actually in a quadrant, but it's living life right on the edge, on one of the axes themselves? Well, that's what happens anytime you have a 0 in your coordinates. Take a look at 6, 0. You move 6 units right, and then 0 units up or down. You're just parked right there on the x-axis. Or look at 0, -7. You move 0 units left or right, and just go straight down 7 units. You're sitting directly on the y-axis. A 0 just means stay put for that direction. Now, the source material for this lesson draws a parallel between the certainty we find in this math and a metaphorical idea, using this quote from Proverbs. The connection being made is that just as we can trust the coordinates to guide us to a precise, predictable location on the grid, the verse also speaks about trusting a reliable guide for life's journey. So, I'll leave you with this final thought. Now that you see the simple logic behind this grid, where else do you see it hiding in plain sight? Think about it. From the seat numbers in a movie theater, to the tiny pixels making up the screen you're watching right now, even to the star charts mapping our galaxy. What other parts of our world are secretly being run by the simple, powerful idea of just two numbers on a grid?